common application of the law of cosines is in navigation. First, we need to define how direction is given as a bearing in navigation. So we start as if we're traveling directly north or directly south, and then we take an angle off to the east or west from there. For example, my first picture here shows north 30 degrees east because it starts out going north and then we veer off 30 degrees to the east. Let's look at some more examples. My second one here starts out going north and it goes 60 degrees west. My next example goes south instead of north, and then 70 degrees west. And then the final example, of course we have to go in every direction, goes south 50 degrees east. So let's look at an example. Two boats leaving the same port at the same time. One's traveling at 30 miles per hour in the direction north 50 degrees east and the other in a direction of south 70 degrees east. It says to see the figure, but we don't have a figure. We want to practice drawing our own figures. So there's my coordinate plane. The first one starts going north, so I think of heading up for north and then going off at 50 degrees east. My second one is headed out south 70 degrees east. And my goal is to figure out how far apart these two boats are after 1 hour. So I could connect those two endpoints and of course have a triangle. So my goal is to find the length of this side. I'll call it x because that's my favorite variable. I can figure out the length of the two sides because distance is equal to rate times time. Both of the boats have only been traveling for 1 hour. The first one is going 30 miles per hour. The second one 26 miles per hour. Now, I have two sides. If only I had an angle, this angle, then I would have a side angle, side triangle, which would be a job for the law of cosines. Well, that angle is easy to determine because if I add together 50 degrees plus 70 degrees plus my unknown angle there, it has to be equal to 180 degrees. So this angle must be equal to 60 degrees. So I can label that. And now using the law of cosines, I know that x squared has to be equal to the square of one side plus the square of the other side minus 2 times the lengths of the sides times the cosine of the angle opposite my unknown side. Plugging all of that into the calculator, x squared has to be equal to 796. So after 1 hour, my boats are about 28.2 miles apart just by taking the square root of 796. Nice application of the law of cosines.